And we're live. Well, I'm adjusting my little screen, my little cover screen here. Come on. There we go. Yay! Wow, we're a little blown out here. That's because I got my cool Jaws shirt on. It's kind of hard to see. There we go. Get all situated here. So we are here. It's Saturday night. Hopefully you guys are all coming. And I see you guys are showing up. Uncle Squirrel, Tim's here. Slayer, Cole, what are you guys doing? Tonight we're going to talk about the last video I posted was on the custom intake manifold that I did on the 463 valve. I also showed a couple of other ones that I did on the 462 valve, and I did 464 valve. I did 5.4 stuff. I did all of these also for LS motors, and I originally the first one that I did was actually for a 5-liter Mustang. And what I did is, like on this 3-valve motor, we saw one that was actually a finished product that actually went in the car and fit and everything hooked up, all the factory fuel rails and lines and fittings and all that stuff worked very well. And the manifold worked very well. Normally what I would do on these is, and you guys saw that I did one recently also for the 4200 that I'm looking forward to testing. And what I do normally is make a manifold that is adjustable so that we can find out, hey, it likes this runner length, it likes this runner length. We can, and it's just cool to, even if we decide that, hey, look, the factory runner length obviously is very close. It likes that. At least it likes that when we have a stock camshaft in it, or the stock cam timing, or you know, depending on what RPM we're running it in, maybe that's going to be very close. But having the adjustable version of that is kind of cool, because when we add a bunch of runner length, we like, hey, look, it made all kinds of low speed power, which is what happened with the 4.6 liter 3-valve motor. When we shorten it up, hey, it adds power up at the top. It's always cool to see that when we test that. And that's why I like making the adjustable one, because it's not any harder to make it like that initially, especially when we're just doing the stuff you saw. I think in the thumbnail, I have a photo up of the adjustable version, and it was actually a dual plenum version. I used those same plenums on the 2-valve, 3-valve, 4-valve, early 4-valve, even on the 5.4, because the port spacing obviously is the same on all of them. So all I have to do is connect those via those slip fit tubing to all of the different versions of those manifolds, and that worked really well. That way we could find out how well they work. That manifold on the 2-valve is the most power I ever made out of a naturally aspirated 2-valve. It was like 400 and almost 490 horsepower, I think, out of an NA version. I think that was actually a 5-liter stroker version, if I remember correctly. And it had ported factory heads. And there's obviously people that have made more power than them. This was way back. But the factory offerings and the other offerings that were available at the time were just not making the power that I wanted. Certainly the PI manifold then wasn't going to. And even the other ones, like the Ricart Racing stuff and the P51 and the things that were available back in the day when I did all this stuff, they were just not doing what we wanted them to do. And so I ended up, well, if something isn't available for what I'm doing, let's go ahead and just make one. And by making it adjustable, we can figure out, you know, in that case, the thing had fairly good sized cams in it, had ported heads. It was more displacement. So it wanted a different kind of manifold. And as we adjusted the manifold, we made a different kind of motor. Some, you know, shorter runners obviously enhanced power at the top of the RPM range. The longer ones made more torque down low. And again, it was kind of cool to see that and to have all of those things. What you end up finding out is that I wish that I had a variable runner manifold, so I could kind of have all of those in all of the different RPM ranges. But you know, that's harder to do. But the manifolds work very well, and I in showing this, I want people to realize that it's not just for the application that I showed you. It's not just for the 463 valve. Like I said, I made it for all these other versions. But guys that are out there that have no other options, if you have a 2.9 liter Ford or some weird Chevy, a 4.3 liter V6 Chevy where there are no manifolds for it, you can make your own. This manifold, somebody made a comment when I posted this that they wanted me to send them the CAD drawing. I just laughed because I didn't do any CAD drawings for this. I didn't do any 3D printing. This was all a long time ago, and I don't have the ability to do that. I just made it. I just drew it out and marked pieces of aluminum and cut holes and had the bends done so that it fit this distance to this distance, this distance to this distance. All the holes that I marked on the plate, I drilled all the holes, made the plenum. We made the plenum not from some CAD drawing or digitized version of the block. I just made it because I made a cardboard cutout to begin with and said, okay, it needs to be this. And then I measure those out and then go, okay, the aluminum needs to be this. And the one thing I didn't do is the actual welding of the pieces that actually needed to be welded. But everything else had to be basically drawn out. And when I say drawn, I mean drawn like on a cocktail napkin, so that when I was looking at it and visualizing, I was going, okay, this is going to go here. This is going to go here. Oh yeah. Now what's going to have to happen with, like, for instance, the design of the 463 valve manifold, the way that the inlet tubes ran, like you only have so much real estate basically to play with. So you have a plate that's as big as, it's as wide as it can be to fit in that valley, and it's as long as it can be to fit in that valley, and it's got to fit in the, where the motor is going to go in the engine compartment. It can't stick back this much farther because other things are going to be in the way. So you have to take into account all of the things that are going to be there with the thing in the car. Because I actually on the 3-valve one, we wanted to make it so it would actually work and go in the car eventually. After we did all the testing on the different runner lengths and decided what we wanted. And when I say we, I mean me. Once I decided that, then it needed to be packaged. So once I figured out what the runner length was, and people have been asking me, well, what is the runner length? And honestly, I don't even remember. I just remember liking that particular power curve because I wanted it to, I was more interested that it enhanced lots of low speed power. So it was longer than, I'm sure it was longer than stock. But because of the packaging that I had to have, the tubes had to go in and curve together and go into the common plenum. And underneath, inside the common plenum has to V down because that's what the V of the block does. So you have to have radius openings inside that plenum. You could just have an edge, I guess, but I didn't want to do that. I had radius entries on them. And as it turned out, they weren't full radius entries like I'd done on some of the other ones, like I'd done inside I showed you, I think, in the video, some of the inside of the plenums of the dual plenum manifolds had like full radius bell mouth air horns and stuff. And then I didn't, that wouldn't fit inside the plenum of the 3-valve manifold, but I just had radius, basically flared ends that were in there. All that stuff had to fit. And then once all of that stuff was in there, if you choose 2-inch tubing and you have to have 4 of them on one side and 4 of them on the other, you have to decide, well, can they crisscross in there? Do they have to go straight down? Do they have to go at an angle because the block goes at an angle? There are lots of considerations, and that's why I kind of draw it out, just to go, okay, that's going to have to fit there. That's going to have to fit there. And then after the 8 runners take up the real estate that's available on that flat plate, and recognizing that they're going to have to go into that V on the inside, then I was stuck with, oh well, now I have to have some sort of inlet going into the plenum from the throttle body. So the ideal thing would be this big tube that would be 3 or 4 inches and that would just go down in. Well, that wouldn't fit. So I did the next best thing because of where the runners were. I had to have 2 individual tubes, one go, and it doesn't matter. They're all both going into a common plenum. So that really doesn't matter, but they had to fit. They had to fit inside the arc of the other runners. And I had to choose, obviously we wanted the runners to be, the entry for the throttle body going into the plenum had to be big enough to not restrict the airflow from the factory throttle body, because why do that? Why make a restrictive manifold, even if it's going to have long runners? Then you're going to end up, potentially losing power at higher, naturally aspirated power levels. So we had to make sure that all of that worked. And there's a lot of considerations that go into this stuff. And people don't realize that when they're doing it. And it would be nicer just probably to draw it all out and digitize it and then draw it. And then you could reconfigure all of that before you went and did it. But I didn't do that. I just made this version. And before we actually started cutting and welding and making pieces, I made versions of like like I said, cardboard versions and stuff that I knew would work and that was easier to work with. So I made for instance, when after we did the cardboard version where I saw stuff was kind of going to work. We're talking cardboard where I'm just bending and taping it together and going, okay, yeah, that looks like it's going to kind of go in there. That's going to sit over the runners. That's all going to work. We're going to have, we've got to transition from round into this ovalish configuration for the ports. We're not going to include the I call them IMRIC plates or whatever, the plates that are covering some of the port for low speed power that they do, which works fairly well. Ford did that on some of their applications. We weren't going to have that. We were going to get rid of that. There are a lot of decisions when you're doing this. And the thing that I like is about that particular video, even though the modular videos don't do well in terms of lots and lots of views, I don't do all of the videos that I do just so they get lots and lots of views. I'm trying to cater to a lot of different engine people. So that's why I do a lot of this other guy's stuff. And the 3-valve is I think the most unloved of all of the modular Ford guys, unfortunately for them. But it's a good motor and it works very well. But I want to do videos on stuff that for the guys that don't get a lot of love. I mean, there's a million LS things out there, and guys should be able to find the answer to any question that they have about an LS online. But a modular Ford guy might not be able to do that same thing with a Chevy Sprint turbo guy, for instance, or there are other engines that fit in that same category, and I like to do those even if not very many people watch them. For me, I like testing them, and I think it's good information for it to get out there. So if you're one of the guys, like I said, that has a weird engine that I haven't even run yet, that shouldn't stop you from thinking, hey, look, I can build my own manifold if there isn't one available. Yeah, maybe they don't make a GT40 manifold for it or a Trailblazer SS manifold for it, but that wouldn't stop you from building one yourself, because it's not terribly hard. If I can do it, almost anybody can, because like I said, I'm not a CAD designer. I don't have the ability to do 3D printing. I've had stuff like that done for me before, and I have a really cool intake manifold to test that was done that way. After I I just did a hand drawing and said, this is what needs to happen, and here are the dimensions that you need to measure, and here are the critical things. And then once that's digitized, then they can make the thing that I want them to make. And I have one of those for an LS, and I haven't run it yet, and it's been sitting now for quite a while, and I want to run it. The thing that I'm worried about is it's not designed to take lots of heat because of what was used to print it with. And I just got to be careful when we run it as not to damage it. But I'm curious to see if it will work out the way that because I did a lot of actually airflow testing and that sort of preparation before I made this manifold. And so it'd be very cool. It's got a giant size throttle opening. It's got like 125 millimeter throttle opening in it, because that's the biggest one I could find. The guy, John Mahovitz, loaned me one of his big throttle bodies and said, if you want to put a big throttle body on there, don't go with the 102 or 105. This is the real one. You need to go with this one. I'm like, oh, okay, well, we'll do that. And so we made that. And I haven't tested it yet, though. I do want to test it. And it actually is a variable runner intake, not a variable. It is an adjustable runner intake manifold. Although we can't adjust it a lot, there is some adjustment in there, and it will be very cool, especially because it's a printed manifold, which I think that the technology is awesome. So I was just over today, just right before I signed on here, I was over with David VIZARD. So if you guys haven't taken a look at what David's doing, he does awesome stuff. Obviously, he's a legend in the industry. He now has the 2.2 liter Dodge head, and hopefully we'll be getting on that. And I should have some flow data from him before too long here. And then they're going to do some porting with it. So we'll do some videos together. Maybe we can get together on some live deals. And then I'll be doing video, obviously, when we do a back-to-back test on the head. So it will be interesting to see how that head compares to other stuff that might be out there. I don't have a lot of flow data on that particular head. It's an early, I think it's a G head. And I don't have a lot of data to compare it to other stuff. So if anybody's seen any stuff and you guys have flow data on them, please let me know. And so we know that when he does this, that we're, what we're kind of shooting for, and what's good and what's good and what's great. Matt, I can confirm he's not a fabricator. Thank you, Matt Mullen, always throwing that shade, man. So that's ongoing, and that will be kind of cool. It'd be cool to see them finally kind of take that apart, and I'm just even curious to see what the stock flow rate is on their bench. And then the other cool thing is that when they flow it, then we can also flow it at Westech, and then we can judge how well I can flow it, and see if there's any difference in the flow data generated over the different lift values. Because obviously we're going to run it from, normally when I run it, we'll run it from 50 thousandths lift to, in this case, we probably would run it up to 600 lift. Even though I don't think we will ever put a 600 lift cam in it, but it's always nice to see. Guys want to know, even if we're only ever going to run a 500 lift cam in it or a 550 lift cam in it, guys want to know if the airflow falls off at higher lift values, because then they can, I don't know, judge whether or not the head is good. If it falls off, then it's bad, or maybe it's better if it falls off. There's going to be all this kinds of arguing, which will be an interesting deal. The cool thing I liked about the manifold test on the 3-valve deal is I got to do the testing both NA and supercharged, which is good, because still, even people watching these videos should know by now that we know that it does the same thing. The manifold is going to determine what happens, like what's the effective RPM range of the motor. If it's short, it's going to be high RPM. If it's long, it's going to be lower RPM. That should be fairly common knowledge by now. But it was cool to see it actually happen. Just like I said, to see it actually happen, changing runner lengths and see the changes in the curves. We know that they're going to happen, and I've done this a lot. So from way back, I kind of know what's going to happen. It's always cool to see it. So it was cool to see this thing do what it's supposed to do, NA, and pick up power down low, and then to see that same kind of thing happen when we had the Vortex supercharger also. Now again, as you noticed, and when I put this in the video, that this intake manifold, when it was run NA, actually didn't make quite as much as the stock one did at the very top of the RPM range. The other thing that happened is on the engine dyno, we didn't get to run variable cam timing, because we couldn't do that with the fast system that we were running with. The cool thing though is Tom, who was there at the time, said, let's just jump at one tooth. We just count the sprocket teeth and go, okay, I think that was about 9 degrees. Let's just jump at one tooth, and we can advance it or retard it and find out what does it do. I mean, if we can't do it with the solenoid through the ECU, let's just do it mechanically. And so we did exactly that. And it did show kind of exactly what you would expect. When we retarded the camshaft, it picked up more power at top. It lost power down low, which again is exactly what you'd expect. We didn't see, I have to say that and I don't know if I covered this in the video, that I did cover that when we were running the manifold in the car, that the gains offered by the manifold were slightly less on the chassis dyno than they were on the engine dyno. And I think part of that is because the factory knew what they were doing. the 3-valve manifold is very good. And with variable cam timing, what they're doing with the variable cam timing fills in part of the big torque changes that we saw from just the runner length. And having the little Emmerich plate, I call it, activated also can enhance a little bit low. But there are still big gains there, just not the same as they were the way that we ran the thing on the engine dyno. So it was still, it's still a good test. And I was excited that, because not very often, I've done a lot of these manifolds for various different applications. And doing, like I said, doing the adjustable ones, especially after I made the plenums for the modular Ford, putting them on every other modular Ford just meant then that I had to do a lower manifold section for those. And the easy way to do this for me was to take, like with the 4.6s or the 5.4s, was just to cut off the aluminum section of the factory manifold and then weld on our tubes to that. And then, so it already had the injector bungs and stuff in it, because that's really the hardest part about making manifold, is getting the injector bungs in there. So we could do that already with some of these applications. And once we have the tubes in place, then they're just slip fit tubes. I just go down to the local muffler place, have them swedge them open. One tube fits inside of another. Most of these are 2-inch. I've done other things where they're only 1 3/4 inch, and I've done other LS stuff where I'm using 2 1/8 or 2 1/4 inch tubing. But again, it's always the same process. You just swedge one end, and then you just slip fit them. And then when we slip fit them, a lot of times we'll just tape them. Honestly, at wide open throttle, there's no vacuum leak there anymore. There is one when the throttle's closed, but when the throttle's open, there's no more vacuum leak there, and the thing acts exactly like it does whether you tape it or not. But a lot of times we'll tape it, and on some of them, I even had couplers that we would hose clamp on both sides of it. I remember doing that on the LS, and that works equally well, especially on the engine dyno. Sometimes the hard thing with these dual plenum manifolds was figuring out how to get because you have to have the linkage somewhat synced. The nice thing about doing it on the engine dyno is that all we have to do really is just go get them both at wide open throttle. So we pull the lever and one of them opens a little bit faster than the other. As long as they both open up all the way, then we're golden, at least for our test. So we're not doing drivability and all that. So it wasn't a big deal. So normally what we would do is just run wires to them and have the wires merged together into a tube, and then draw it, through the back of the motor on the back of the dyno, and all of that was fairly easy. Sometimes we'd do it from the side, link them together, but whatever you have to do to figure, that's all easy stuff to figure out. And once you get them at wide open throttle, it works very well. So I was able to make lots and lots of those manifolds and test lots and lots of them, which is very cool. And you didn't see this in the thumbnail, but on some of these things, the runner length, the stack is gigantic. I think we tested 20 or 22 inches of runner length on these things. And so as long as I keep having the tubing, and we could just keep stacking it together. So I would make 2-inch sections, and then 4-inch sections, and then 6 and 8. And then by the time you're stacking them all together, the thing is pretty tall in the dyno cell. But luckily that all fits, and it's easy to find out, hey, look, when we run a ton of runner length, it makes lots of low speed torque though. So again, all of this, and I kind of got off on a tangent, but if you have a motor that doesn't have an aftermarket intake manifold for it, there's nothing stopping you from doing it. And if you take, if you have a 4-cylinder and nobody makes a manifold for it, if you cut off the factory section and weld on aluminum tubing to it and do what I did and make a plenum, you shouldn't care about what the shape is or any of that. Just make some kind of round plenum. I call them mailboxes because they're a flat plate with the tube sticking out of it, and then they just got a bend around it that looks like an old school mailbox. You have a throttle inlet. Don't worry about the angle of the throttle inlet. The plenum doesn't have to be tapered. It doesn't have to. None of that has to happen. Just make it and run it and just see what happens. And if you make it adjustable, you can do some fairly cool things. You could do some things that the factory manifold doesn't do. Or the other thing you find out is the factory manifold on that motor actually works pretty well. And that's what I found out when I was doing all of the trick stuff, because I did this with the Honda B series as well. I even had a dual plenum manifold that I made that paired cylinders, that paired 2 cylinders and 2 cylinders, and each of those 2 cylinders fed into a common plenum. And then I had those two joined together in the back, and 2 throttle bodies and all kinds of stuff. And what I found out was factory Honda manifolds work really, really good on factory Honda motors. So it's, it's all cool stuff. So let's see what you guys got going on. Let's see what we got going on here. Oh, Cameron. Yep. Yeah. Let's see. I saw you pop on David's video. Yeah, David's a good guy. He's like the real deal. Those guys know some stuff. Yeah, I don't like the cylinder head with the integral exhaust manifolds, Tim. We had problems with that on the Volkswagen, and it's just we tried porting it and did all kinds of stuff, and it was just what we needed to do really was just replace the head with one that doesn't have that we could make our own, because we were trying to do a turbo deal, and they're trying to do it for packaging and heat retention and all kinds of stuff, and what we were doing it for was just not very good. Yeah, and the turbo's bolting right to the head. A lot of times it's again, I don't like that because of the temperature, and that's an aluminum or aluminum cylinder head, but that's the way that they had it. Yeah, again, the reason that they're doing that on the integrated flange with the head is that they want the cat light off to be immediate and stuff. The A90 Super BMW engine has turbo bolted right to the head. Oh, so they did switch over to a different design in the BMW? That's good. They should. You're going to de-stroke and debore your K10. Yes, on both of those. We're not going to debore it. I'm going to de-stroke it. So Durham, you're going to go with hybrid or all electric? So Bo, you think you can get some resonance tuning by adjusting the secondary right off the head before the turbo. So you think that a length of exhaust tubing between the head and the cat, or between the head and the turbo, is going to give you resonance? Piston valve clearance issues with a stage 3 truck cam and a 30 mil 799 head. I doubt that. There's not enough duration in that camshaft. So brain damage. Thanks for singing the praises. So a replacement engine was $19,000 in the Tesla. Any plans on testing the Enforcer LS1? I haven't run that yet. I can talk to them about it. I don't see why it wouldn't be a lot better than a factory head. How are you going to make your Honda K10? We're going to just de-stroke a K20. There's obviously more to it than that, but that's what's going to kind of happen. Hey, Richard, love your channel. Hey, my friend Andy keeps talking about this exhaust. Says something about how the emission works in logs as units. I would need more information. Donovan, do you think that there's any reason I can't make an adapter plate to move the intake runners and mount a Hellcat supercharger on a big block? I think what would you could definitely do that. So yes, you can do that. I think what would be easier is for you to buy the lower intake manifold for a blower manifold, like for a 671, and then make an adapter plate off of that. That probably would be easier because it might be a much easier plate to mount a Hellcat blower on there. Notice the trend on almost no length intake manifold design recently. I haven't noticed that. There's factories have no intake runner length? Maybe on a turbo or forced induction application. It would be fun to see how much power a Fiat 1.4 multi-air could make with just ring gap. I remember looking into those motors. I want to see your long runner intake sticking out of the hood. It would be kind of cool. It is very, very Mad Max-ish. Richard, have you kept an eye on the electric actuating valves? I have not. A couple content creators are writing their own code to program outside the major. Are you talking about actuating valves for like the intake and exhaust valves? Is a 99 BMW 528 wagon any good? Yes, it is. It's a good candidate to put something else in there. If it's running good, it's a good one just to drive around, but it's an even better one with even a stock, some sort of LS in there. The 2022 Ford Lightning is going to be full electric. I haven't seen that. If the letterbox, it's a mailbox. The letterbox plenum has a really tight turn to the first cylinder. Is there a risk of that cylinder running rich due to not getting the same airflow? I haven't tested that yet. I'd like to see if that happens. A lot of people envision airflow going and going past that, but that's actually not what's happening. It's more so the case probably on a forced induction application, and more so probably at higher flow and boost levels. But I think what happens is when you pressurize the plenum, I would be interested to see, and this is one of the tests that I'm going to do on the RB25, is we're going to do individual cylinder map readings and find out what the pressure differential is on the different cylinders. And we're going to do that with the stock intake and then with the Greddy style short runner intake with that sort of plenum style to find out if once you pressurize that, do we see a difference in pressure and therefore flow in the individual cylinders based on that intake manifold design. I would like to see if that's the case. Now, we know that we get a difference from changing the runner length. If you make, for instance, on the V8s, you have a single plane intake that has long outer runners and then short inner runners. If you feed them all the same amount of fuel, the air-fuel ratio will definitely be different cylinder to cylinder. There's also issues with if that thing's carbureted or how you're supplying it fuel, but I'm talking about if you have port injection, there's going to be a difference. And there would be a difference if you had different runner lengths in an inline six-cylinder like we're talking about. Luckily, it's fairly easy to make them all the same. So I would be curious to see if there's a big difference in plenum volume or design to see if that equates to big changes in cylinder balance. How to determine intake runner length without testing. You can get a fairly good idea from all of the information that's out there. I mean, take a look at the factory one. If you want to have more high-speed power, like you want it more top end, make it shorter than the factory one. If you want more bottom end or possibly even more power through the whole RPM range, you can make it longer than that. Oh, I've designed some long tube stuff on VSIC applications, old GTPs, Supras, Servo. Are you talking about long tube exhausts or long tube intakes? What is a flat cam? I don't know what a flat cam is unless you're talking about a flat tappet cam. But if people are talking about it on a Ferrari 458 and a Corvette, they're probably talking about a flat crankshaft. That's a different thing. Have you cut any factory intake manifolds shorter with success? I'm tempted to remove about 50 millimeters from my BMW track car intake runner length to increase it tune frequency about 100 RPM, 1,000 RPM. 50 millimeters is about 2 inches, and 2 inches is not going to make 1,000 RPM difference. It won't do that much. But if you look at if you compare a BMW M series motor to their non-M series counterparts, you'll see that they have much shorter runners in them. I found that the factory mod intake works better than the Dorman replacement one. The runner length is way shorter than the factory Ford manifold. Definitely lost low RPM torque. Oh, are you talking about, you must be talking about the 2-valve Dorman replacement, right? I didn't realize that it was different. I thought it was actually a copy of the factory one. A 1-liter D-stroke K series won't make less torque than the Sprint does. New design, if the port off the head is the same size as the secondary from that log to the engine, it looks like one runner. Yeah, Donovan, if the motorcycle has really high compression, if you drop it down a bit and add boost, that will work. A 403 holes, 4351 bore, and a 3.385 stroke. That is a good combination. It's unfortunate that they never gave them enough cylinder head or intake manifold or camshaft to work. But again, just because it has a bore and stroke that might, I guess, potentially be favorable. The thing is that 400-inch motor with those heads, cam, and intake is going to make the same power as a different bore and stroke combination, like a small block Chevy that has the same stuff. It's the fact that it has a big bore and a short stroke is not going to benefit it unless you put it in an environment where it can benefit from those, like where you run out of cylinder head, and then having the big bore allows you to have a really big cylinder head on there that it could then take advantage of. But in its current form, the bore and stroke are going to be irrelevant. See, Dan, people have been saying that for years, and I'd like to actually see that I'd like to see pressure taps on various places on the manifold to show that that's actually happening. Are you Helmholtz residences? Are you still talking about the exhaust, Bo? Yeah, and the math on the intake runner length comes from organ pipe theory that has been around before the advent of the internal combustion engine. So it's all pretty well known. Yeah, variable runner is if you can make a long runner for low speed power and then a short runner for high RPM power, that works really good. Like the Acura Integra GSR was like that, and there are other examples of where the factory has done that because they like having both of that. You know, like I said, whenever we do a variable intake manifold and we do a long one, it makes a lot of torque, and we do a short one, it makes more horsepower. The ideal situation is to have both of those, and be able to have all of those. But that's very hard. A stock 283, except for a 350 horse 327 camshaft, which is good. That's the L79 camshaft at a 142 blower. The 142 blower is going to be the thing that dictates the power, but that should. Is it a 4-barrel? I'm hoping. And with the 142 blower, it's going to be over 300 horsepower. I'm thinking you're going to be more like 350 to 370. Beans and Hermie, yes, David VIZARD is the real deal. He knows what he's doing. You worked at a GM dealership and you know a thing or two about flat cams. We've flattened some flat tappet cams before, pre-flattened. Helmholtz is not reflective wave, though. It's a different thing, Bo. Helmholtz is the resonating frequency of a given volume, and a reflected wave is the wave that is initiated by the opening of the valve with a downward moving piston. It's a negative pressure wave that goes up to the plenum and then goes back down to the open port. That's a different thing. Helmholtz resonance is happening while that reflected wave is happening, and also while inertia ram is happening. So all of those things can sometimes work together, a lot of times work against each other, because you may have a negative pressure wave happening at the same time that a positive pressure wave is happening. There's a lot going on there, which is why it takes quite a bit of computer power to figure out what's actually happening, and why they always run stuff on the dyno to figure out what's happening when they design an intake manifold. And in my opinion, Helmholtz resonance is the least effective of the three major forms of charge filling associated with an intake manifold design. We showed you the video that I did on the Keglodon, where we changed the plenum volume by 1,000,000 times, basically, and it did essentially nothing. BMW Vanos thing is good. That's just variable cam timing, and that works. And BMW also, Dan's right, had continuously variable intake, where it was like, if you think about a snail shell, if you sectioned a snail shell, and kind of like that. There was a supercharger that was like that too. BMW used, or Volkswagen used one. Their G-Ladder supercharger was like that. It was a scroll supercharger. That's what the BMW intake is. It rotates in itself and can change the runner length a lot, dramatically, and changes it on the fly, which is kind of cool. Why does a Dart 540 rev so high and the 454 or 632 will not handle RPM all day? I didn't know that they wouldn't. The RPM potential of the motor is a function of the valve train first, and then whether it's going to make power up there or not is going to be determined by like the power things that you put on the motor, like what cylinder head did you use, a lot by what camshaft you use and what intake you use, and a 454 with equal parts on it that the Dart 540 had will rev higher because it's a smaller motor. And so if you have lots of camshaft in it, lots of camshaft in a smaller motor wants to make power higher than it does in a bigger motor, typically speaking. I'm assuming that the 2.2 that I ran, that we did the startup on the stand start, it seems like it's healthy. Yes, the 4-rotor Mazda at Le Mans also had sliding trumpets. Brain damage, you ask whatever question you have, man. That's why we're all here. There's lots of good guys to answer stuff if I don't know the answer to it. No, we won't, Dan. We won't run the Sprint turbo engine at Bonneville. I wanted to. That's what originally we were doing when that Sprint got stolen. We were prepping it. I was going to run the motor that I have. It would already have set the records, because we'd already went faster in the standing mile than the record was at Bonneville. So that would have been easy. This one is something different. The Formula SAE guys know what they're doing. That's some serious stuff there. And having a continuously variable intake trumpet length, they had those in Formula One until they outlawed them. And now I'm told that maybe somebody was telling me that they may have brought them back. But I know that when they were using them, they were not just doing long runner, short runner thing. And they weren't just doing that it's long runner at low speed and short runner at high RPM. Because what you'll find, and this is one of the cool things you find when you test like I did with the variable runners, is that as you change the runner, you're going to change the sine wave basically. And so you see a power curve that kind of goes like this. And then when you change the runner length, the big gain and then the big dip are shifted over a little bit. So what you want to do is if you change them by 2 inches, you shift the sine wave over a few hundred or 100 or 200 RPM or whatever the number is. What you want to have is you want to have the tops of all of those and never have the dip. And so what they did was actually cycle this runner while it was going through RPM. They cycle it to have the best average power of all of that, not just a long run or short runner thing. It's pretty kind of cool. Ever do any testing on plenum volume on the dyno? Yes, lots. Like I said, if you take a look at the video I have up on the Keglodon, I took and we changed the effective plenum volume from what a fast intake is to what a beer keg is. And there was no change in power. And also I've done more realistic stuff where we've taken, for instance, when I did the variable or the adjustable intake manifold offer by fast for the LS3, we put the long, medium, and short runners in there. And then, as luck would have it, the fast LSXR lid, the low profile one, you could take that off and remove it and put the LSXRT, the bigger, taller truck one in there without changing the runner length. So all you're doing is affecting plenum volume. And again, it had little or no change in power when we had a fairly big change in plenum volume. Slayer of Souls, I have a 283 with a miss. So you flatten the camshaft. It's probably a flat tappet cam, and you lost a cam lobe and or a lifter, and that's fairly common. But that's really easy to fix. Do you think you could test runner length on a fabbed manifold? That's all of these are fabricated manifolds, head and intake runner versus intake runner alone. I don't understand what the difference is. If you're changing the length of the intake, you're changing the length of the head and the intake. The head staying fixed. Modifying the runner length of the cylinder head is very hard to do because then you've got to mill it away or something. But changing the length of the runner in the intake manifold is like I said, the head stays fixed. That length is fixed from whatever the port entry is into where the valve is. And then you just do it with the intake. So I don't really understand what you're wanting to do there. Yeah, Dan, we went through a lot of that at Wastegate too, changing to light springs, putting the light ratio rockers on there, putting lots and lots of moly-based assembly lube, both on the bottom of the lifter and all over the camshaft, and then running high zinc oil and all that stuff that we did. How much timing do you typically run on pump gas on 91, on 5.3? In the car is different. When we run it on the engine dyno, the thing's cold. So normally these things kind of run best at around 29 degrees total. And there'll be less at the torque peak and then less down low because they don't need that timing when we load it in at 3,000 RPM. I still have the Nova. VA House Casino, where is that, Andrew? Oh, the flat plane crank. Okay, that's a different thing. Yeah, Brian, people don't realize when you start doing the math, I'm amazed that things even work when the piston is going up and down that many times at 7,000 RPM, and then the valves are opening and closing that many times. And so what they don't realize is that this air column has to go in and out, and when these reflected waves happen and how often they're happening and what their effect is, and that they happen multiple times during the cycle. And there's a lot going on there. That's why an internal combustion engine like this is fairly complex. Helmholtz resonance is a resonance wave. It's determined by the volume. So when you excite a given volume, the example I always use is a drum. If you hit a big drum, it makes a different noise because it has a different resonance frequency than a small drum. Same thing with a plenum. A smaller plenum resonates when you excite it, and we excite it by running it in the engine. When it's excited, it resonates at a given volume. And so when it resonates, you have pressure waves. Those pressure waves, if they arrive properly at the right time, can improve cylinder filling. But that's what's happening. And that's why it doesn't add very much in terms of power, not compared to runner length and not compared to the inertial ram, which a lot of people get confused between Helmholtz resonance, and they call other things Helmholtz resonance, which actually is not. The Nova is not in the same place as the 455 Buick. .403 Ols versus a 400 big block Ols, everything being equal. Did they make a 400 big block Ols? And is the see in a comparison like that, the problem is I don't know how you get the intake manifold the same and the cam timing the same and the head flow the same. That's a hard test to do. Isn't the record for a production body, production engine, blown gas, 1 liter over 200 miles an hour? That's not what you're describing there is not one of the classes at Bonneville. He would be in a specific class, and if he's in an MR2, he would be in like modified sport probably. Yeah, and Bo, I didn't even get into the fact that, like, on the reflected wave, you have a change in amplitude from the secondary and tertiary waves. There's a lot of stuff that goes into this. Beans, yeah, you can do taper. That's called runner taper. You can taper the runner and have a decreasing size, internal size, and there's argument as to whether that actually increases the velocity compared to and so you have to be careful about how you're comparing it. One thing that's happening here is we know that if you're comparing a tapered runner to a straight runner, the straight runner is going to have more volume. So there's a difference there. If you're comparing a tapered one to the same size runner that's the same diameter as the smallest part of that, then the tapered runner is going to actually be bigger. So the question the test that you'd want to do is to find out which one of those three offered the best performance. Does runner length make a difference on carburetor motors? Yes, it makes a difference on every motor, any kind of motor, carbureted, fuel injected, whatever. Super glue a cog on the front of the keg manifold and tell people blower without a belt. How critical is runner length with the wet manifold and boost? The runner length matters no matter what you're doing to it. it does the same thing. The runner length determines the effective operating range, whether you have fuel going through it or air going through it or whatever. It doesn't matter. What I was asking about the intake head runner length is to see if theoretical intake measurement can be fine-tuned by factoring the head runner length with it. Well, the head is part of the tuned runner length. So you have to, when you're doing calculations, you don't just do the intake. When I'm talking about we change the intake runner length this amount, that's because we don't ever change the head. The head's fixed. So when we change the intake runner length this amount, it did this kind of power. The head is already part of that. And if you're doing calculations with software, that you have to know what the head port length is also. The trick would be to get the peak of the sine wave as long as possible through the greatest possible RPM range. I picture the trombone section of a band. Yeah, but what happens is when we're just changing the runner length, you have a sine wave that's a given amplitude, and when we changed the runner length, I don't remember. I had to go back and look now that you've said this. I want to go back and look to see if we've made the waves shorter and peakier or longer and and smaller effectively when we changed the runner length. I don't think that we did. I remember them kind of being the same, just shifted over. But eventually we get to the point where when we get really short runners, we know that they stretch out and go down. So now I need to do more information. See, that's why I come here and talk to you guys. What time would you run for a 6-liter 408 NA? I would look at it at around 29 degrees of total timing, and it would be less down low. If you could talk to a Formula One engineer, what would you want to know about the engine? I would want to know everything. That's why I have the Ferrari Formula One book that cost me more than probably every other book that I own. And it has really good stuff in there. Why don't we musically tune the plenum? You can. You can do it with a tuning fork. Richard, not sure if I missed your answer, but do you want a Kenny Bell boost to spark for carb boost motor testing, or not trying to sell you anything? I know the guys at Kenny Bell really well. I can't remember the last time we used a boost to spark. I'm making a manifold for an 8-plug Ford 2.3, or plan on running Harley-Davidson carbs. It's going to have a common plenum and try to either link the carbs or run them sequential. Okay. Does a B-flat plenum run better than a A-sharp? I think it's all about the G and the C, because those are the only chords that the Ramones use, which they did very successfully. Terry, the only thing that's his question is how critical is throttle body size versus charge pipe size? That's not critical. The only thing you don't want to do is have the throttle body so small that it restricts flow and that you get a buildup of pressure there. If you're boosting through it, chances are the throttle body is going to be more than big enough. I wish you'd do some kind of testing on fuel separation in port runners and how if it separates, then exhaust temps go up and down. Some clear runners with bend to show fuel dropout. That would be cool. Is timing advance important with boost, or is it lock timing and only pulling timing when under boost better? Your timing should be tailored to your boost curve. So I don't know what you have. If you have a centrifugal supercharger, the curve for that is going to be different than it is for a turbo or for a roots blower, because it's also going to be dependent on other things. If it's fuel injected, it's going to be dependent on air temperature, on water temperature. Other things are going to affect the timing curve. Paul, I don't know enough about your combination and what your converter is and what the car weight is and the heads of the cam or any of that stuff. So it's hard for me to say on those turbos. 270, 875s probably are not going to, unless if you're trying to max them out, I mean, that's going to make a lot of power. But it'll be easy for you to find out if you put them on, and you can monitor back pressure and find out if back pressure is your problem. Turbo 32, I read your book. My twin turbo 4.6 Cobra motor in my 32 coupe has the 2001 Cobra intake. That thing works really well. Bigger throttle bodies have poor low speed drivability, so you want the small throttle body. That's absolutely not true. Throttle bodies have almost nothing to do with part throttle drivability. In fact, what will happen with a bigger throttle body, it won't have worse drivability. If anything, it's going to feel a lot better, because at any given throttle position, it's going to have a lot more airflow because it's bigger. So it's going to be really super responsive. And a lot of times that's not as good, but it won't. A lot of guys think that a bigger throttle body, they liken it to a bigger carburetor. Like, oh, I get into a bigger carburetor, it's all boggy and it's not responsive. Bigger throttle bodies don't do that. All of the response rate of the motor, of a fuel injected motor with a throttle body on it, is determined by other things that are going on with the tune and the manifold and the camshaft and stuff, not by the throttle. The throttle does almost nothing on a fuel injected combination. Legit question: does the angle of a wastegate to exhaust flow have any importance? Yes, the angle of the exhaust flow relative to the exit of the wastegate has an effect on the effectiveness of the wastegate. So the flow rate of the wastegate itself and its response. So most people tend to have a turn where the wastegate gets straight air, straight exhaust going to it, and then the turn goes, and then the turbo is mounted there. So if you look at most real Indy or Formula One kind of race cars, that's the way that they plummet. So I'm assuming that that's the optimum thing. That being said, there's lots of stuff out there where people just stick it out at a 90 degrees, which I don't like, but sometimes you have to do for packaging. It's better if it's in line with the flow of the exhaust. Why do carb spacers change power on a single plane if the plenum volume doesn't matter? That's a really good question, and I don't know. The answer is that we know that it changes what's going on with the carburetor if we do see a change. A lot of times I don't see a change with an open spacer on a single plane manifold. It doesn't do anything because it already has a big open plenum and the signal is already bad to the carburetor with a single plane. Sometimes we do, but what I would like to do is I would like to run that test, and I haven't done this yet, and we've been talking about this at Wastegate for a long time, is I want to do a single plane manifold with port injection on it and run the test we would need to run it on a combination where when we do a carb spacer on an open, like on a single plane, where we do an open carb spacer and it makes a difference. Then if it does that on the engine combination, because a lot of times they don't, if it does do that on that carbureted combination, I want to see if it also does that on a port injected throttle body combination with that same intake manifold and that same engine. So if we replace the carburetor with a 4-hole 4150 throttle body and then do the before and after open plenum with it fuel injected, because what I want to know is it just changing the signal to the carburetor, which is changing the power, which can happen, or is it changing the plenum volume, which is changing the power, which in that case, I'd like to know why that's the case, because in all the testing I've done in plenum volume, it doesn't seem to make a very big difference. It allows the air to be cooled by fuel longer because there is more runner length. Putting a spacer under the carburetor has no effect on runner length. It only has effect on plenum volume. Aaron, that's true. I mean, if the runner length is longer because of the deck height, then the longer runner length would have an effect on power. But in the case that you're talking about, you're also changing other things. The heads cannot be identical, obviously. At least I don't think they can be. Richard, will you be testing NA intakes on the 3800? Yes, I will. Runner inserts versus runner. The runner inserts on which intake manifold? Which intake manifold has runner inserts on it? Manitoba Black. Okay, maybe I did. Maybe that's what you were talking about. The situation we were talking about was as you get into the throttle, it becomes like really jerky and responsive because of the amount of airflow. I always use the example of the Ford Focus that I had when we put a 65 millimeter throttle body on there and then port matched the factory plastic intake manifold. When we put that thing on there, it felt like super responsive. Oh, I picked up a lot of power. Well, at wide open throttle, we didn't pick up any power. But because now at a 25% throttle opening, we were now flowing 100% of the air that we were flowing before on the stock throttle body, because it had that factory throttle body in that case had the like angled ski jump and the rising rate throttle opening, and they did all that stuff for drivability, which the other aftermarket throttle body did not have. So when it opened up, we got a big hit of airflow. And that made drivability, in my opinion, worse because it was harder to modulate low-speed throttle. And it's even worse on a big throttle body on a Roots or twin screw blower. So if you put a big throttle body on like a Kenny Bell blower, man, it's pretty responsive. The NA 3800s have runner inserts. So the front wheel drive ones do, like the composite manifolds do. Aaron, if you build a 302 base engine, a 351 built to the same cubic inch, same head, same cam, Fiddlebrock Performer intake, will a taller deck height make torque? Well, again, the problem is we can get the same compression, we can get the same displacement, we can get the same camshaft because all of that works on the 351 and the 302 and making the same displacement. The intake manifolds will be different. They won't just be different because of the deck height. They'll be different. So the port passages are different. The design obviously is going to be similar, but it is going to be different. It's not just going to be the same, but longer. And that's what you're trying to point at. And unfortunately, we're changing two things there. I do miss racing. Is it true that a dual plane will react differently or better support a larger carburetor? Yes, I think that that's the case. What happens is you, in a single plane intake manifold, you lose carb signal. So if you were at like 2,500 RPM or whatever, and you mash the throttle on a single plane intake, it doesn't want to make power until high RPM. So the signal to it will change dramatically. There won't be very much carb signal to it. On a dual plane, when you do that, you'll have lots of carb signal because you've divided effectively the carburetor in half. So the signal is much better. We know that because when we go from a single plane to a dual plane intake or vice versa, we have to dramatically change the jets in the same carburetor because we have to add a bunch of jet to a single plane, not because it makes more power, because it has no signal. So it needs more fuel for that amount of signal, and that can only be done with having more jet. The L36s have the plastic insert that you can pull out. Okay, good. That will be cool. If it's kind of like the design lends itself to being adjustable, that's awesome. John, very cool stuff. Hi, mate. I have a Boss 260 with a single 66 millimeter turbo. I'm using a standard Boss inlet manifold. I wish I had a Boss intake manifold. Those are awesome. I want to run a different top with 2 throttle bodies. What size throttle bodies should I use? You're going to run a single turbo with 2 throttle bodies? Are you doing? I don't understand why you're doing that. I mean, 2 obviously is better than 1, but I don't really understand why you're wanting to do that. Unless you're putting another turbos, then blowing through 2 throttle bodies. Again, awesomeness. But just make sure that the 2 throttle bodies are flow as much as the single that you already had. So yeah, we were saying the same thing, Manito Black. I just jumped all over you for no reason, for apparently. Yeah, and the Quadrajet is another example of that. It's small primary so that it had good throttle response. On my Olds 455 with the Victor intake, the signal was quick. It's not. It's less than it would be with a dual plane. It always is. It has to be. There's no way around that. What is the timing retard formula when adding nitrous to boost? Same air fuel. Just read the plugs. Was a good starting point. How much are you running? The safe thing is you're already pulling timing because you have boost. So if that's working for you, then we normally pull 4 degrees of timing with the nitrous per 100 horsepower. So I would start there, and then if you see that it's okay, maybe go up a little bit. And also, the amount of timing that you would be pulling with the nitrous is going to be fuel dependent. So if the air fuel is fine, and adding nitrous, the air fuel, you can actually run it leaner with the nitrous than you can with boost, but it's still going to be rich because of the boost. But if you have excess octane, you don't have to pull as much timing away. Like if you're running 10 pounds of boost and you're running 100 shot and you have C16 in it, you probably don't have to pull a bunch of timing. Bob Norwood. I met Bob Norwood before. I and H, blown gas. Okay. So H is 1.5 and I is a 1 liter. Which would you prefer, old 90s Ford EFI or something like a Holley Sniper or Phytech? I don't like, if the Sniper you're talking about is the 4-barrel throttle body thing, I won't run one of those. If it's a 90s Ford EFI and I'm running it on a 1990 Ford Mustang, the E4 stuff works very, very well, especially if it's a mass air deal. And since you can program that works really good. If it's already in the car, I probably would tend to use that, or I would use a Holley probably. Yeah, a single plane makes more power at top and a dual plane makes more power down low. For 6,000 RPM or even some 6,500 RPM, depending on the displacement of the motor, we tend to recommend a dual plane for street applications. As you go up in displacement, the recommendation slides back, goes more toward the single plane, because with more displacement, you'll have naturally more torque. And so you won't be giving up the same amount down low. Have you ever done any testing on a 2-stroke piston engine with runner plenum volume? Oh, the only stuff we've done on a 2-stroke is I did my GoPed and we put a pipe on it. And that's all the 2-stroke stuff I've done. Uncle Squirrel, I reached out to Tony and I had not heard anything. Jimmy, why does a single plane intake work better with EFI than a dual plane? In my opinion, it doesn't. The single plane and dual plane do what both of those do, regardless of whether you have fuel injection on them or a carburetor on them. I have a Phytech EFI on a small block Mopar and wouldn't respond properly with the Performer intake. I don't know why that would be the case. Jojo, that's the problem with the LT stuff, and that's one of the reasons that I think a lot of guys are shying away from it, is that the price of the fuel system upgrades on them are pretty expensive. Noodles is in the house. Yeah, you know what throttle body is really cool, and I wish somebody would do this in the aftermarket, is if you look at the throttle body on the old LT5 ZR1 Corvette engine of, I think it was 1990 or so, it had a very small primary one, and then after that, the two other big blades would open up. So it had 3 holes, basically, and so you could have like lots of low-speed drivability on the tiny primary one, and then the big butterflies would open up, and I think that the aftermarket should do that, because that would be cool. Can pulling too much timing under boost. The timing that your boosted combination is going to run is going to be a function of the NA timing, and then backing that off based on how much boost you're running. If you're getting a backfire, I would check plug gap. I haven't, I'm not anywhere near done with Atlas testing. What sounds the best? 3D printing stuff is so much easier than making aluminum ones, if you can do that. Yeah, I met Bob out at the Road and Track Top Speed Shootout that I took my Mustang to. I took my supercharged Mustang to. Rick Titus drove all the cars, and he was there with that crazy GTO body deal with some sort of twin turbo big block or something in it. Yeah, the ZR1 also had the valet key too, which shut off the secondary injectors. Okay, this is the last question. I got to get going. Any recommendations on how to boost horsepower on a TPI? I have all the TPI intakes. I know you're saying that you don't want to change the intake. You can do all of the normal things that work on a small block Chevy. You can do a cam, you can do heads, you can do a throttle body, you can do headers. All of those things work. It's just that if you have the stock tune port or something like the stock tune port, an aftermarket version of that, it's going to limit where you can make power. So if you just take that stuff off and put a dual plane on it, you'll get a lot more power. So the tune port stuff is designed to make power below 5,000 RPM. And on the factory one, it's going to be closer to 4,500 RPM, especially if it's on a 350. So you're going to be limiting yourself with that design, but you can get a little bit more power with a cam. You can get it with better heads, more compression, long tube headers, all of that stuff. All right, guys, I got to get going. Thank you all for showing up. I'm working on a video right now on a 4.8 liter turbo stuff, naturally, different size turbos, all kinds of cool stuff, showing you what happens when we run out of turbo, essentially, and what happens when we put a bigger one in place of it. Guess what's going to happen? It's going to make more power. Thank you guys for all showing up. I will see you all tomorrow.